Welcome back. So let's look at static equilibrium. And static equilibrium is a condition on how we can examine different exercises in a pretty simplistic way. And static equilibrium merges the concept of internal torque, which is muscle force times the IMA, or the internal moment arm, and external torque, which is the external force, or whatever we're lifting, and times the external moment arm. And in static equilibrium, internal torque is equal to external torque. And so the question is, what type of muscle contraction is happening in static equilibrium, which is like a snapshot? And that would be an isometric contraction because we're looking at it statically, so there's no motion. Okay, back to mechanical advantage. Mechanical advantage is when the moment arm length is relative to the resistance arm length, or the force over the resistance. And in our case, say a mechanical advantage equal to 1 indicates the IMA, or our internal moment arm, and the external moment arm are equal, right? So the external moment arm is the resistance arm length, and the internal moment arm is our muscle moment arm length. If we have a gain a mechanical advantage greater than 1, that indicates that your IMA is greater than your EMA. And if you have a mechanical advantage that's less than 1, or a mechanical disadvantage, that indicates your IMA is smaller than your EMA. So let's look at some instances. So our first class lever system, it could be either, right? You could do a crowbar example, or they can be balanced, your IMA and your EMA. In the second class system, your resistance, or what you're trying to lift, is closer to the axis. So that moment arm is shorter than your, say, muscle or your force producing moment arm. And in the third class system, it's reversed. The force, your muscle force, has a smaller internal moment arm compared to what you're lifting. So that there's a long external moment arm and a shorter internal moment arm. So for the first class, either the muscle or the external force can have the advantage depending. Second class, our muscles always have the advantage. And if you remember from the lever video, there are very few second class lever systems in the human body. And in the third class, our muscle has the disadvantage, and the majority of our joints are third class levers. So then we ask, why are we built like this? Why are most of our joint lever systems third class lever systems? Well, human leverage system is built for speed and range of motion at the expense of torque production. So that means we're not the strongest, and we're necessarily not the fastest, but we're pretty strong and pretty fast.